Today we will be starting with the new chapter, that is probability. Already you have studied the basic concepts in your first PUC. Here you are going to study some more concepts, and here this chapter is very important. Probability is nothing but it is mainly based on the logic. Here solving part will be less. So you need to understand the logic behind that question. Then solving will be easy. So it will be little, the thing is you need to understand the question, what is given and what you have to find. Those things are very important here. Okay, and total weightage of this chapter is 11 marks, and this is very important for your CET as well as for JEE. And here 11 marks in the sense 1 mark 1 question will be there, 2 marks 1 question, 3 marks 1 question, and 5 marks 1 question. Total it is 11 marks. First, what is meant by probability? Probability is a measure of uncertainty of any event in the random experiment, right? Probability is a measure of uncertainty of any event occurred in a random experiment. And you have studied about the sample space. Sample space is represented by S, right? And how you have studied how many elements how to find the elements in the sample space. How many elements occurs in the sample space. And you have studied about the any events E or F and finding the probability of those events. That is you have studied. Now here we are going to discuss about one important concept, that is conditional probability. This is the first concept of this chapter, conditional probability. Okay, conditional probability. See here, the name only says you are finding the probability, but there one condition is given. So that is named as conditional probability. Let us consider a event, okay? Tossing a coin twice. Listen carefully. Tossing a coin twice. Okay. I have considered one probability, one event, that is tossing a coin twice. Now what are the sample space? How many elements will be there in the sample space? Sample space is represented by S. How to find the number of elements in this? Simple, it is tossing a coin twice. Coin have two faces. One is either head or tail. So number of elements should be 2 to the power 2. So it will be equal to 4, right? Then the sample space should contain 4 elements. What are the possibilities? One is head and head is possible, right? In the first coin head and second coin is also head. Or head and tail is possible. Or tail and head is possible. Or tail and tail, right? So this will be the sample space. So sample space includes the 4 elements, right? So probability of a sample space is always 1, because 4 by this is 1 by 4, right? This is probability of this will be 1 by 4. 4 elements are there, and probability of this is 1. Or else what we can say, probability of head will be 1 by 2 into probability of head is 1 by 2. So it is 1 by 2 into 1 by 2 will be 1 by 4. But usually we will not use this one, directly we will write. Here 4 elements are there, so probability of this will be 1 by 4, probability of this is 1 by 4, probability of this is also 1 by 4, and probability of this is 1 by 4. If I add everything, it will be 4 by 4, it is equal to 1. Sample space is having a probability is always 1, because it includes all the elements, right? So this is the sample space. Let us consider our event, okay? Head occurs exactly once. So clear? Head occurs exactly once. Now can you say what are the elements? Event E. Head occurs exactly once. So this always the event will be a subset of a sample space, right? Event is always a subset of a sample space. Here I have considered head occurs exactly once. Now what are the elements? Can I consider head and head? No, because here head occurred twice. So this is not possible. Head and tail, yes, it is possible exactly once. So one element will be head and tail. What about tail and head? Possible. Tail and head, one head is there. So I can consider tail and head. But tail and tail is not possible because it is exactly once head should occur. So this is the one event E. Now let us consider F. Okay. Head occurs any event you can consider, okay, at least once. Head occurs at least once, or you can consider head occurs, or you can consider tail occurs exactly once. Okay, any event you can consider. Here I have considered head occurs at least once. Now what are the possible elements of F? Head occurs at least once. At least once it should be there, head or more than one. Possibility, head and head is possible, once or more than one, right? So this is now head and head is possible. Next, head and tail is possible. Then tail and head is also possible. But what about tail and tail? It is not possible, right? So this is the event F. Now, what is the probability of E? What is the probability of E? How many elements are there? 4. Sorry. How many elements are there? 2. And sample space containing 4 elements. So what I can write, probability of E is equal to 2 by 4. Actually what it is? Probability of, see here, one I will write, probability of E is equal to probability of HT, okay, plus probability of TH. Now what is the probability of HT? This is 1 by 2. Probability of H will be 1 by 2. And probability of T is also 1 by 2. So this is 1 by 4. Right? 1 by 2 into 1 by plus. Again probability of T will be 1 by 2. And probability of H will be 1 by 2. So 1 by 2 into 1 by 2 will be 1 by 4. So it is equal to 2 by 4. Right? So here we will write directly probability of E is equal to now 1 by 2. Now what is the probability of F? What is the probability of F? Here 1, 2, 3 elements are there. So probability of F is equal to 3 divided by number of elements in the sample space will be 4. So this is equal to 3 by 4. Right? Now this one you have studied in your first quiz. Now here observe carefully. Here we are finding the probability of E directly. And here we are finding the probability of F directly. But here the conditional probability is nothing but you are finding the probability of some event, okay, that is, okay, there will some condition will be given. For example, if I say probability of an event E, probability of a event E, I mean the conditional probability, okay, the conditional probability of an event E that F has occurred. Is it clear? This is called the conditional probability. I mean you are finding the probability of an event E with respect to F. I mean F is already occurred. Okay? Understood? And try to understand this. See, conditional probability is nothing but you are finding the probability of a one event, but there one condition will be given that another event is already occurred. Based on that you are finding the probability for E. And one more thing you have to remember, those events, if I consider the event E and F, both should be a subset of a sample space. And for the both event, the sample space will be same. Okay, we cannot consider that one is a tossing coin and another one is a throwing a die. That is not possible. That events, both the events should be belongs to the one sample space. I mean both the events should be a subset of a sample space, same sample space. Then only we can define a conditional probability. Note this one. Actually for this to find the conditional probability, there one formula is given. Okay. First we will write let E and F, if E and F be two events, okay, be two events occurred with same sample space, okay, it should be in the same sample space. Same sample space, this is very important, same sample space of a random experiment, okay, of a random experiment, then the conditional probability of, then the conditional probability of E where F has already occurred. Is it clear? This is very important. You are finding the probability, I mean conditional probability of an event E where F has already occurred and it is denoted by P of conditional probability of E by F. Is it it clear? We are finding the probability of E, I mean conditional probability of E, where F has already occurred is given by number of elements in E intersection F divided by, okay, number of elements in F. Now see, this one I can write as number of elements in E intersection F divided by n of S divided by number of elements in a sample space, both the side. So this is n of F divided by n of S. Now what is this? Number of elements in the E intersection by n of S. So it will gives you a probability of E intersection F, right? So this is the probability of E intersection F divided by n of F divided by n of S will be probability of F. Okay, no need to worry about these things. Just the thing is, you have to remember conditional probability of an event E with respect to F or F has already occurred is given by P of E intersection F divided by P of F. This is an important form. Okay, we'll solve some problems based on this so that you can understand. Okay, this is nothing but you are finding the conditional probability of an event F where, you are finding the conditional probability of an event E where F has already occurred is given by P of E intersection F divided by P of F. Now here can the same example. Here tossing a coin twice, that is sample space. This is event is exactly, head occurs exactly once, or you can take tail occurs exactly once. F is nothing but head occurs at least once. It is head tail, tail head and head head. So these are the possible. Now you are finding the conditional probability of an event E. Okay, F has already occurred. You are finding the conditional probability of you are finding the conditional probability of E and F is already occurred. F is already occurred is nothing but favorable to both. The element common in both. So this is defined as P of E intersection F divided by P of F. Right? First we'll find the intersection of these. Intersection is nothing but the element is common in both. Right? So E intersection F, what are the elements? HT is common and TH is common. Right? So that is remaining, one more is not there. So this is TH and HT. What is the probability of this? Probability of E intersection F will be equal to 1 by 4, right? Plus 1 by 4. Is it clear? Probability of TH will be 1 by 4. 1 by 2 into 1 by 2. It will be 1 by 4. This is also 1 by 2 into 1 by 2. 1 by 4. It is equal to 2 by 4. I can write 1 by 2. Right? So this is now is equal to probability of E intersection F will be 1 by 2 divided by probability of F. What is the probability of F? It is 3 by 4. Right? 3 elements are there. Sample space 4. So this is equal to 3 by 4. So I can write this as 1 by 2 into 4 by 3, 1, 2. So this is equal to 2 by 3. Is it clear? So this is the answer. This is the final answer. You found the probability of a conditional probability of a event E where F has already occurred. Remember important one. Properties of a conditional probability. Simple it is. Let E and F be events of a sample space S. Okay. That means E and F are the subset of S. Then P of S by F is equal to P of F by F will be equal to 1. Obviously, right? See here P of S by F. By using a differential mode we can write S by F. You are finding the conditional probability of S. F has already occurred. So this will be P of S intersection F divided by P of F. Right? So this is equal to, now what is the intersection of S and F? Here F is a subset of S. Obviously S intersection F will be equal to P of F. Right? So this is equal to now P of F divided by P of F. So both will get cancelled, is equal to 1. Now I think you can prove this. P of F by F. So this will be now P of F intersection F divided by P of F. P of F intersection F will be equal to P of F by P of F, that is also equal to 1. Okay. Remember this is the first property. P of S by F is equal to P of F by F will be equal to 1. So the second property, if A and B are two events of a sample space S and F is an event of S, okay, A is a subset of S, B is a subset of S and F is also a subset of S, such that P of F when probability of F is not equal to 0, then P of A union B by F is equal to P of A by F plus P of B by F minus P of A intersection B by F. Now can you say which formula we have to use to prove this one? Which formula we can use? Simply, which formula? You have the formula, right? P of A union B. You have studied in the first PUC. P of A union B is equal to P of A plus P of B minus P of A intersection B. Right? We need to use that formula to prove this one. Now here one more condition is given. In particular, A and B are disjoint sets. Now can you say, in particular A and B are disjoint is nothing but the intersection of those will be equal to 0, right? So here I can say this is equal to 0. So in particular, if A and B are disjoint, we can write this as P of A by F plus P of B by F, because intersection will be equal to 0. Now we'll prove this one. Simple it is. Okay, I'll consider that first. P of A union B by F. Now by using the definition of a conditional probability, we can write this as P of, right, A union B intersection with F divided by P of F. Clear? Just we have substituted in the formula. Now A union B intersection F. By using a distributive law, what we can write? P of, see here, A intersection F, A intersection F, union B intersection F, yes, divided by P of F. Clear? Now, it's of the form P of A union B. As I told you, this is the P of A union P of B. What is P of A union B? P of A plus P of B minus P of A intersection B. We have studied that formula. So this is now I can write P of A. P of, in the place of A, I have A intersection F plus P of B is now B is B intersection F. P of B intersection F minus P of A intersection B. A intersection B will be now A intersection F intersection B, right? A intersection F, B intersection F. What we can write? A intersection F intersection B, because once F is enough, right? So it will be A intersection B intersection F whole divided by P of F. Now we'll rearrange this one. I can write P of A intersection F divided by P of F plus P of B intersection F divided by P of F minus P of, we'll arrange this one, A intersection B intersection F divided by P of F. Clear? Now what is this? P of A intersection by P of A. This will give you P of F, P of A by F, right? P of A by F is nothing but P of A intersection F divided by P of F. So this will be now plus P of B by F minus P of A intersection B by F. So prove, right? P of A by F plus P of B by F minus P of A intersection B by F. How to prove this one? In particular, if it is A and B are disjoint sets, then obviously A intersection B will be equal to 0. That is nothing but P of A intersection B by F will be equal to 0. By using this, we can write P of A by F plus P by P of B by F is equal to P of A union B by F. This is an important property. We will see one more property. Okay. See, this is another important property, third one. Only three properties are there. See, P of E dash by F is equal to 1 minus P and E is the event, E dash will be the element which are not in E will be equal to E dash, right? Now to prove this one, this is an important one, okay? P of E dash by F is equal to 1 minus P of E by F. Now by using the first condition we have P of S by F is equal to 1, right? P of S by F is equal to 1. So this one can be written as P of S, can I write this as E union E dash by F is equal to 1. Can we write like this? P of E union E dash by F. S is equal to E union E dash. See here, S is a sample space, E is the event, okay? Then E dash is the event which are not in E. Is it clear? S is a sample space and E is a one event and E dash is the event. Then those elements which are not in E, those are in S. We have to list everything. If I find the union of these two, E, right, A union A dash will be equal to universal set, like that. E union E dash will be equal to yes. Is it clear? So I can write yes as E union E dash, since E and E dash are disjoint. Now by using this one we can write P of, what is E union E dash? Just now we have seen the second property, right? E and E dash they are disjoint, right? Since they are disjoint, this will be equal to P of E by F plus P of E dash by F is equal to 1. Is it clear? I hope you are getting this one by using this formula. P of E union, last one E union, A union was there, right? P of A union B by F was there. If it is these two are disjoint, A and B are disjoint, obviously here E and E dash are disjoint. If it is this is a condition, we can write this as by using the second property. P of A by F plus P of B by F. Yes, this was the second property in that particular condition. So here we can write this as P of, in the place of A we have E, P of E by F, in the place of F, anyway F is there, P of E by F plus P of, in the place of B, here we have E dash, P of E dash by F is equal to 1. By using this we can write P of E dash by F is equal to 1 minus P of E by F. Okay, so this is another important property. Remember, so or else you can write P of E by F is also equal to 1 minus P of E dash by F. Remember these properties. Now we will solve some problems based on the conditional probability.